Solve the rational inequality. We have 28 divided by x plus 4, which is less than or equal to 7. So here's our rational inequality, okay? And the first thing that we want to do is, before we can find the interval boundaries, we need to make sure that we set this inequality to have a 0 on the right side. So the first thing we need to do is to subtract 7 to both sides of the rational inequality. So when we do that, we get 28 over x plus 4, and that's minus 7, which is less than or equal to 0. I'm going to write this over 1 because what we want to do is we want to combine that into one term on the left side of the equation. So now we need to determine what is the LCD between 1 and x plus 4. Well, the LCD between 1 and x plus 4 is x plus 4. So that means, what do we have to multiply by 1 to get x plus 4? Well, it's x plus 4, which means we need to do the same thing to the numerator. So that's 7 times x plus 4. Remember, this is less than or equal to 0. Now, what do we have to multiply by x plus 4 to get x plus 4, which is 1? So 28 times 1 is 28. So now in step number 4, we have 28 minus 7 times x plus 4 over the common denominator of x plus 4. And we want to see if that's less than or equal to 0. So now we need to distribute the negative 7. So for step 5, we have 28 minus 7x, and negative 7 times 4 is negative 28, all over x plus 4. That's less than or equal to 0. 28 minus 28 is 0. So we have negative 7x over x plus 4, which is less than or equal to 0. So now we need to determine our interval boundaries. So when we take a look at this rational inequality, we have negative 7x over x plus 4, and we're going to set that equal to 0. So we're going to take the numerator first, which is negative 7x. We're going to set that equal to 0. If we divide both sides by negative 7, then one of our interval boundaries is 0, because 0 divided by negative 7 is 0. Step number 3, we're going to take a look at the denominator. The denominator is x plus 4, and we're going to set that equal to 0. When we solve for x, we get x is equal to negative 4. And remember that this is a restricted value, because if we plug that into the denominator, it's going to make it undefined. So we cannot include the value of negative 4. Okay, now we're going to now write step number 6. So we have negative 7x over x plus 4, and that's less than or equal to 0. Okay, now let's draw our number line so that we can include our intervals. So here's our number line. We have 0 in the middle. We're going from negative infinity to positive infinity. We know that one of our interval boundaries is 0, and the other one is negative 4. So we have interval 1, interval 2, and then interval 3. So for interval 1, it's going to go from negative infinity to negative 4. For interval 2, we're going from negative 4 to 0. And then from interval 3, we're going from 0 to positive infinity. So now we're going to go ahead and then find our testing points for each particular interval. So for interval 1, we can choose negative 5. So x is going to equal negative 5, and now we're going to plug it into the rational inequality here. So we have negative 7 times negative 5 divided by negative 5 plus 4. We want to see if that's less than or equal to 0. Negative 5 times negative 5 is positive 35. Negative 5 plus 4 is negative 1. 35 divided by negative 1 is negative 35. And is that less than or equal to 0? Well, that is true. So therefore, it's true for interval 1. Let's try interval number 2. We can pick negative 1. So x is going to equal negative 1. So we have negative 7 times negative 1 over negative 1 plus 4. I want to see if that's less than or equal to 0. Negative 7 times negative 1 is 7. Negative 1 plus 4 is positive 3. And so is positive 7 over 3 less than 0? Well, the answer is no, so therefore it is false. So it's false for region number 2. Okay, now for region number 3, we can pick x equals 1 and then plug that in. So we have negative 7 times positive 1 over positive 1 plus 4. And so we want to know if that's less than or equal to 0. Negative 7 times 1 is negative 7. 1 plus 4 is 5. And therefore this is negative 7/5. And a negative number is less than 0. So therefore it is true for region number 3. Okay, so we know that it's true for interval or region number 1. And it's true for region number 3. Now, how do we write this interval? Okay, well, we know that this is less than or equal to. So remember that 4 is a restricted value, so we cannot include the negative 4. So we have parentheses negative infinity, comma, negative 4. Okay, and then we know that region 3 can include 0 because it's not a restricted value, so it's bracket 0 to positive infinity with the union symbol. And so therefore there is our solution set. Let's go ahead and put that into our answer to check. So we have parentheses negative infinity, comma, negative 4 with parentheses and the union symbol, the bracket because we're including the 0, comma, positive infinity with a parenthesis. Check our answer, and there is our result.